As mentioned in previous videos, safety for theater and lighting specifically is very complex. You should never do any electrical work that you are not 100% confident in, as it could lead to serious injury or death for you or other people. However, there are a few basic ideas and suggestions that can really help your understanding both in and out of the theater when it comes to working with electricity. The power formula is a simple but critical equation to avoid overloading your system's electrical setup. In electrical systems, the standard unit for power is watts, and you may be familiar with a wattage rating on light bulbs and theater fixtures. Wattage describes the maximum amount of power they require in watts at their rated voltage. Now we have an issue. Our extension cables have a current rating in amps, our power supply rated in volts, and our fixtures a power rating in watts. What do? Well, the equation relating power, current, and voltage is actually extremely simple. It's called the power formula, and it says that the electrical power, watts, is equivalent to the electrical potential in volts multiplied by the electrical current in amps, or W equals V times A. You might also hear it commonly referred to, especially by theater students, as the West Virginia equation, referring to the mnemonic device often associated for memorization. This simple formula can help reinforce the safe operation of electrical equipment in your space. Let's break it down. The W in the equation stands for watts, or more simply, the power consumed by each lighting instrument when it is in a fully on state. For instance, a 100-watt light bulb uses 100 watts of power, whereas your 5-watt phone charger only supplies 5 watts of power to charge your phone. The necessary wattage for an instrument or for any item can be pretty easy to identify, as it should be listed somewhere on the label or in the manual. You will need to identify this number for each item you are intending to plug into your system, so make sure to take note of that when purchasing equipment, as this number will become very important soon. The V in the equation stands for volts, or the amount of electrical potential available for the instruments to use from a given source, like a wall outlet or battery, for example. So for instance, a 9-volt battery has 9 volts of electrical potential available. A wall outlet is one of the most common sources of power, and in the United States, 110 volts is the standard output in most outlets in homes and businesses. Most of Europe, on the other hand, has 220 volts as a general standard, which is why power converters can be incredibly important when you're traveling. We are definitely able to find 220 volt outlets in the United States, even in most homes. We just might not notice. Ovens, dryers, and other large appliances often require the additional power to function correctly, and that power is delivered more efficiently at a higher voltage. You can usually identify the 220 volt outlet based on the shape of the outlet itself, which is intentional to avoid accidentally plugging the wrong item into the wrong outlet. If you are using standard wall outlets, though, it is important to remember that each outlet isn't its own 110 volts, and is usually connected to a greater system of individual breakers. And each one could include multiple outlets or other electricity drawing units in the space. So it is important to remember that it isn't 110 volts per outlet, it's per breaker. I strongly encourage you to consult an electrician or lighting designer to look into the voltage in your space before you start plugging things in if you aren't aware or sure of the answer. The last letter of the equation is the A, which stands for amps or amperage. This number refers to the amount of electricity that can be safely pulled from the power supply through the cable and into our power-consuming device. Extension cords and extension lighting cables come in a number of thicknesses and sizes, which are in turn able to handle different levels of electricity. When electricity passes through a cable, those electrons create heat as they move from one end of the cable to the other, and at a certain point, too much power can actually cause the wiring to overheat and melt the cable, resulting in damage to the cable, your equipment, or even a fire. The amperage number or rating is usually determined by the thickness of the cable used and should be easily found on the packaging of the cord, as well as somewhere on the extension cable itself. The thicker or heavier duty cables can handle more electricity safely, So it is always important to check the actual numbers in your space and on your items before plugging anything in. When considering amperage in your walls of your performance space, in the United States, there usually varies between 10 amps per breaker in most homes and up to 30 amps for heavy-duty systems. This information can be found by just looking at the actual breaker on the breaker box, usually written right on the breaker. Again, if you have questions, are unsure of anything, or can't find that information, check with your electrician or lighting designer for more assistance before doing any work. Safety first. Now, putting that all together, we can use the given information in your performance space to figure out how many watts we are able to safely plug into the breaker using the power formula. As long as you keep the watts consumed side lower than the power safely available side, you should realistically have no problems. For instance, if you have a 15 amp breaker and 110 volts of power available, you would be able to safely plug in 650 watts of power total. Don't forget, that is for the entire breaker, so always check to see what each breaker controls. If there is a 100 watt bulb though, hung overhead in the same system, you'd only have 1550 watts of power safely available to use, and so on. Let's do another example. In this case, let's say you plan to have 4 individual 25 watt LEDs and 5 individual 100 watt bulbs in the same system, but you still need to buy the extension cord to connect them. In this scenario, you can calculate 100 watts of power needed for the LEDs and 500 watts of power for the incandescents for a total of 600 watts. We can then add in the 110 volts of power available and solve to see that you need to purchase an extension cord that can handle at least 5.454545, or rather 6 amps of power safely. I always like to check my math 3 or 4 times before starting work to make sure everything will be safe. And as usual, you can always consult a lighting designer or electrician to check your math for you and confirm that what you are planning will be safe. Now that we have the power formula down, let's talk about some other tips to help improve the safe operation of your production. The first thing I want to cover is the use of power strip surge protectors, specifically those with the on and off switches, but more on that button soon. If you are working in a space that is not a typical theatrical space, there is a very good chance that the total electrical power available might not be as much as a typical theater. Most power strips include a circuit breaker, which is designed to trip if too much current is being drawn from the outlets on the power strip. Most North American power strips will include a circuit breaker rated for 15 amps of current. This is good extra protection to help avoid accidental overload by tripping the switch if too much electrical power is being used by the fixtures, especially in a guerrilla setting. When an overload event occurs, you will probably hear a power strip click, which is the mechanical sound of the breaker tripping. First, determine if any unsafe conditions have occurred, either that caused the overload or resulting from the overload, such as a blackout where performers cannot see how to exit, or because someone tripped over a wire or a fixture. Once you have corrected any issue with the circuitry that may have caused the overload, you can reset the breaker. Each power strip will have a little black circular button that will pop out when the overload event happens. Others just require flipping the power switch to reset and then back to on. One of my favorite final ideas for these guerrilla-like situations that I have used on more than one occasion when necessary, but definitely needs math to ensure safety, is to have multiple surge-protected power strips connected to each other with 1 or 2 main power strips controlling the group. This option, while it looks like a horrible idea from an 80s movie, when done safely, gives you the ability to create an overall blackout in a space that otherwise wouldn't be possible, simply by hitting 1 or 2 switches. As mentioned before, please make sure to calculate the safe wattage you can plug into each breaker before actually plugging things in. When thinking of hanging or mounting lighting instruments, another important safety item to consider is to use safety cables. Whenever you hang or attach something overhead, you need to attach the unit to a safety cable and the safety cable to a solid load-bearing structure, such as I-beams or lighting pipes. Never clip or attach to any electrical pipe or anything that is not securely attached to the building. The safety cable is meant to catch the instrument should any portion give out, and if it is attached to something that could be ripped down, or in the case of electrical pipe, expose interior wires at the same time, it can create an even more dangerous situation than a falling instrument alone. I recommend checking with your space's technical manager or technical director to help you make an informed decision. Safety first. When thinking about running lighting cables from your instrument to a circuit or wall outlet, especially if you are not able to run them up and get them secured into the lighting grid, away from the actors and audience, you will want to consider options to avoid creating a trip hazard. If a cable does need to run through a space where it may interact with a person, whether in the audience, on stage, or backstage, the first step is to make sure everyone who could encounter the trip hazard is aware of it. This may include posting a sign or even sometimes having an usher keep surrounding folks aware of the potential trip hazard. Second, whenever possible, tape down any loose cables to either the floor or the wall. The method I prefer includes putting small strips to taut the cable and then full coverage to secure the trip hazard. I tend to attach the top and then use 2 fingers to smooth the sides into place, keeping the cable in a well-contained space. Sometimes taping a cable isn't possible, so in that case, it is incredibly important to make sure everyone who needs to know about it is aware of the possible danger, and that they make an effort to avoid cables whether they are taped out or not. Another interesting challenge you might run into with existing theatrical instruments, or for a variety of reasons, is having different plugs and different outlets. So for instance, you are needing to plug your instrument into a standard Edison wall outlet, but it has a twist lock or stage pin plug, or vice versa. Some form of plug conversion needs to be considered. So while it is possible to plug those theatrical instruments into an outlet or power strip surge protector, after considering the power formula first, of course, the easiest option is just to purchase an adapter to convert from one plug style to the other. You can also talk to a lighting designer or electrician about actually converting those adapters permanently to whatever your setup in your theater space has, and just being done with it. Please, do not take this upon yourself to do without proper training and guidance. Purchasing the adapter is way safer. Some final quick safety tips include always making sure any equipment you use does not include frayed or damaged wiring. Second, if you intend to do your own lighting, budget for and buy your power strip surge protectors now, and label them lighting department to eliminate the chance of losing them to the general need of others using things that plug in. Just helpful tips from past experiences. And finally, if it feels unsafe, it probably is, and you should consult your electrician or lighting designer before doing anything that feels unsafe. I know I keep emphasizing this point, but I cannot stress the importance of safety for you and your team. No show is worth a person getting seriously injured or possibly dying from doing something that could easily have been done safely by someone who knows for sure.